So, in this video, we're going to prove that this sum, 1 plus 3 plus 3 squared all the way to 3 to the n minus 1 is equal to 1 on 2 times 3 to the n minus 1. And we're going to prove that for all positive integers n using mathematical induction. Firstly, let us denote the statement S of n be the relation that we need to show, that is, the left side equals the right side. What I've written here is somewhat of a rehash of the question. Now let's start with the basis step. In this step, we want to show that the statement is true for the lowest possible integer. Since we are proving for all positive integers, we will start with 1. Showing the statement is true simply means showing that the left-hand side equals the right-hand side. The left-hand side equals 3 to the 1 minus 1, which is equal to 1. And the right-hand side is equal to 1/2 of 3 to the 1 minus 1, which is also equal to 1. And so we have both sides equaling 1. So our basis step is now complete. Now on to the inductive step. We first assume that our statement is true for some fixed positive integer k. It's always useful to write out this by substituting k into the statement like this. It is useful because we will make a substitution in the next part. So we now must prove that our left-hand side equals the right-hand side for n is equal to k plus 1. I like to write out what this will look like before starting the proof. Here we can see what the left-hand side and the right-hand side looks like for n is equal to k plus 1. Now let's get into some work finally and start with the left-hand side. So our left-hand side is equal to 1 plus 3 squared all the way to 3 to the k minus 1 plus 3 to the k, which is our last term. Here we've reached a very important step. Take a look at the first k terms, that is from 1 up to 3 to the k minus 1. At the beginning of the inductive step, we assumed that this equaled 1 on 2 times 3 to the k minus 1, and so we will make our substitution. Therefore, on our left-hand side, we now have 1 on 2 times 3 to the k minus 1, and outside of that, a plus 3 to the k. We can then multiply the 3 to the k by 2 to get a common denominator, giving us this 2 times 3 to the k, seen here, with the 1 on 2 factored outside. It seems we can simplify the 3 to the k term, which is nice. 3 to the k plus 2 times 3 to the k is equal to 3 times 3 to the k, and we will still have the negative 1. Well, we know that 3 times 3 to the k is equal to 3 to the k plus 1, and in changing this we get our right-hand side, consequently proving our statement is true for n is equal to k plus 1. Now for the conclusion. Since S of n is true for n is equal to 1, it is true for n is equal to 1 plus 1, which is equal to 2. Therefore, it is true for n is equal to 2 plus 1, which is equal to 3, and so on. Therefore, our statement is true for all positive integers. So we have completed the question and the proof by mathematical induction. Thanks for watching.